Hi everybody, I'm Geordie from Fronius Australia, and I'd like to welcome everyone to this tech talk about the emergency backstop mechanism in Queensland and how you can fulfill this requirement with a Fronius inverter. Okay, so firstly, who does this affect? As mentioned, this emergency backstop mechanism will affect people in Queensland. You can see the network operators in Queensland here that are involved. So people who are part of the Ergon Energy and Energex network will be affected by the new mechanism. So you or your customers might ask, what is this and why is it in place? The simple answer is that network operators need to maintain a balance of supply and demand for electricity. As the level of rooftop solar has increased, this has led to a surplus of supply, especially during the middle of the day. And this imbalance of power can cause blackouts, which we all want to avoid. So what does this requirement do to prevent the issue? The emergency backstop mechanism requires a device called a generation signaling device, or GSD, which will communicate and control your solar inverter in emergency situations to prevent blackouts. So the communication to the inverter will be via the demand response management ports, or DRM ports. The DRM ports are a standard communication interface used to ramp up or down or switch off or on an inverter remotely. In other situations, you may have actually seen these get used for load control, like in air cons or pool pumps. And for this emergency backstop mechanism, only one of the DRM modes will be used, which is DRM 0, only using 2 wires, which will be used exclusively to turn the inverter off and on. The communication from the GSD to the utility will be done through the audio frequency load control, or AFLC system, which will be done over the power lines. And this is going to be a form of power line communication directly to the GSD. And this signaling to turn off and on the inverters remotely is only going to be operated by network operators in an emergency under the direction of AEMO. And currently, Ergon and Energex have only approved one GSD, which is sold by TMAC, and the cost is around $70. Okay, so the next question is, when will it be implemented? On the 6th of February 2023 will be when installations in Queensland are requiring the use of GSDs, so we don't have a great deal of time left. Don't worry, if you still have any questions after this presentation about how to fulfill this requirement with a Fronius, don't hesitate to contact us at Fronius Australia as well. Okay, which sites? So Ergon and Energex's website has a table for the types of IAS connections that require GSDs. For the latest information, please check their website, as this could be subject to change. But I've put the table in the slide here to give you an idea of what key criteria is asked for to determine whether a GSD is required or not. Now, just to give you a general overview, currently the requirement impacts sites where the total inverter capacity is equal to or greater than 10 kVA. However, there are some exclusions and different requirements depending on the situation. So, for example, warranty cases, if you're expanding an existing system, AC coupled batteries on site, etc. So, again, please be sure to check the latest information from Ergon and Energex about which existing or new devices will require a GSD. There's also some fringe of grid areas that aren't serviced by the AFLC system in Queensland. For this, you can check Ergon and Energex's website, which has an NMI search, and you can see if the area is included. So check this before going to site, because you may not need a GSD for those areas. Now let's have a look together at what's compatible and what we need to do to install a Fronius inverter with a GSD. Okay, so how do we install a GSD with a Fronius? So for the first thing, depending on the inverter, so if it's a GEN24 or a Snap, there are different setup processes for each, and both can have the GSD retrofitted to them. And in the middle is the GSD. So this is what it looks like. You can see there's a mains cable that comes out. This is for power, and of course it's got the RJ45 connector here, and an RJ45 adapter, which is what we'll be using for our inverters. So this will go straight over the top of the RJ45 connector, and it breaks out into this gray wire and yellow wire. and they will be what connect into our inverters for the DRM controls. So let's start off together by seeing what we need for a SnapINverter.
Okay, so please keep in mind before setting up our Fronius solar inverter with a GSD, you will need to commission the inverter. The best way to do that is, if you're not sure, go to our website or go to our Fronius Solar Energy YouTube channel for some help. Once the inverter is all set up and commissioned, you're ready to go now to install a GSD. So what you're going to need is a DRM interface card. You can purchase one of these from our sales partners as an optional extra. You'll also need a laptop or a smart device, and of course you'll need a data manager card, which is found inside most of our SnapINverters. The first thing is to turn the inverter off before we change any connections inside the inverter. So the next step is to remove the two screws from the base plate to remove the plate itself. So we undo both of them like so, and the plate will come out, and we'll be able to see underneath there's an orange terminal block, and the data manager card is already inside. The first thing we're going to do is we're going to remove this terminal block, and then we're going to undo the screw here. And that'll come out. So the next step is to put the DRM interface card into the bottom of the inverter here like that. And then you'll need to fit a screw that will go straight into here, like so. And that will hold it into place. Okay, so the next step is to put the orange terminal block in that came with the DRM interface card, and then plug the pre-wired connector into the bottom of the interface card.
Okay, so we just went through step one, which was to install the DRM interface card. And as a recap for the process, we're going to need, number one, a smart device. This is for the next step, and you can use the same device you used to commission the inverter. You'll also need a DRM interface card, which we installed in step one, and a data manager card, which comes standard with a full version of the inverter. However, if you have a light version of the inverter, you will need to retrofit a data manager card to that inverter. Now, before we move to the next step, we're just going to go through some of the finer details here. So a question you might have is, what if there are multiple SnapINverters on a site? Do you need to have multiple DRM interface cards and multiple GSDs? So the answer to this depends on whether all the inverters are connected together in the same solar net loop. So in a solar net loop, multiple SnapINverters are connected together via the in and out Ethernet ports in the inverter. There will be one master inverter, which contains the master data manager, and the rest of the inverters are connected, are slave inverters. So the master inverter is the only inverter that requires a DRM interface card and the GSD connection. The other inverters don't require any DRM connections apart from being in the same solar net loop. So this means you need to have one DRM interface card and for each master data manager on site. So if there's one inverter on site, you need one DRM interface card. And if there's two inverters on site, just like this picture here, and they're connected together in a solar net loop, you only need to connect the DRM interface card to the master inverter, and then you connect the one GSD to that interface card. And that's all you'll need. Okay, so the next step, now that we've commissioned the inverter, we've connected the DRM interface card, the next step is to activate the DRM controls. So firstly, we start off by activating the Wi-Fi hotspot or connecting your laptop up to the LAN port of the data manager. And then you open up a web browser with the IP address that's shown here, so 192.168.250.181. And then the screen will display just like this. You'll be able to see some information on the local server here. The next thing we want to do is go to settings on the right-hand side here. So when we click on that, it will prompt us to log in. We need to make sure to log in as a service user with the drop down here. So once you've selected service and you've typed in the password, log in, and you'll be able to see a menu that looks like this. And the next step is to go to the DNO editor at the bottom. Once we click on that, we'll be brought to a menu that looks like this. And the reason we enter this menu is to make sure that the IO control is the top priority for our power controls. Having this as the top priority means that DRM controls will take precedence over any other form of control. And this is critical It's regardless of any export control or any external Modbus control settings, as DRM will always take precedence over those controls. And this exact same check is done with the Gen24 process. I'd like to emphasize that you must remember to check this during our IO mapping step here. So all we need to do is actually just scroll down. Once we scroll down, we'll see the control priorities. Now, this is a check. We may not necessarily have to change anything, but we need to check this. So we've got IO control, dynamic power reduction, and controlling via Modbus. If you need to shift the priorities around, you simply need to click on the up and down arrows beside the function to shift it up or down. If no changes need to be made from the default settings, again, this is fine. If we did change something, we just need to remember to click on the tick box at the top here to save our settings. And once we have this done, we can move on to the next step for activating the DRM connections on the next slide. The next step we want to do is go to the IO mapping. You can see the interface here showing the IOs at the top. These are the IOs of the orange terminal block, which we installed before. And this is the pin assignment of the actual terminal block. So below are the pins that are being assigned to particular functions. And there's the predefined DRM function here. So all you need to do is click on this tick box here. Once you've clicked the tick box, then you just need to click the tick at the top here, and that will save the settings. You do not need to change any of the pins here. The defaults are completely fine. And once this has been saved, the DRM ports are actually ready for use. And now we can connect the GSD to the inverter. Okay, and to do that, all we need to do is put the RJ45 adapter over the top of the RJ45 connector. So now we've just got the yellow cable and the gray cable to connect. And from here, we just connect the yellow wire to RG0, which is just here, and we need to connect the gray wire to CL0. And as you can see, we're actually only using the two connectors on the interface card here. We aren't using any of the connections on the orange terminal block. These were just the pre-wired connections. And once we've connected the yellow wire and the gray wire to these two ports here, the SnapINverter is actually ready to go. And the inverter is connected up to the GSD and operational for the emergency backstop mechanism. So just to summarize, the requirements: we need a laptop and a smart device. We need a data manager card, which should already be inside the inverter, unless you've got a light inverter, in which case you may need to purchase a data manager card. And for every SolarNet loop or master data manager card, you just need one GSD and one DRM interface card. And the steps are just commissioning the inverter first, then connect the DRM interface card to the inverter, set the IO mapping, and then connect the GSD to the DRM interface card. Okay, so next, let's have a look at how to connect a GSD to the Gen24. Now, this process is even more straightforward because no DRM interface card is required for the Gen24, and all you need is the GSD and a smart device. So firstly, using the smart device, you need to connect to the Wi-Fi or LAN of the inverter and type in the corresponding IP address as shown in the slide. So we just open up the access point and we type in the password to connect to the Wi-Fi, type in this IP address here, and if we're using LAN, you connect up to the LAN port, open the access point and type in this IP address. So again, I just want to emphasize we do not need a DRM interface card for this. It's simply just setting up the IO mapping and then connecting the GSD. So now that we've connected up to the inverter's IP address, we'll be able to see this menu here. We can see the settings on the side here are all locked. So what we need to do is to log in first. So once we log in, we need to make sure we log in as a technician, as we can see here. Once you've logged in as a technician, you'll notice that all the locks have actually disappeared and now you have access to everything you need. The next step is to click on Safety and Grid Regulations. Once you click on this, Then we'll need to click on IO Power Management, which will bring us to this menu here, and we're able to see our controlling priorities. Now, this is something that we really need to check before we go any further. We need to make sure that IO power limit is our top priority. This check is something we should do while we're doing our IO mapping step. You may not need to change anything because it could be like this by default. However, if you do need to move any priorities or something has been changed in the background, you can hold and click on any of these priorities and drag them to where they need to be. If you do move them, a save button will pop up at the bottom, which you can then click on to save. So at the end of it, we need to make sure that the IO power limit is our top priority here. And this will keep our DRM functions active and working no matter what. Once we've got that done, then we can click the back button here for the safety and grid regulations, and it'll take us back to the original menu so we can proceed with activating our DRM controls. The next step is to actually click on device configuration. So we can see that on the left-hand side here. Once we've clicked on that, we'll have a menu that looks like this. And then we need to go to the functions and IOs. And this looks very similar to the Snap layout. And we can see here there's a predefined Australia demand response mode tab. All you need to do is click on that and turn the toggle switch on. And this will actually set all the default pins to what they should be. And it will map the IOs straight ready for DRM use. Okay, and once this is done, all you need to do is hit the save button, and then the Gen24 is ready for GSD installation. So there are some other cases. So if some of the IOs are already being used for something else, or let's say, for example, you're using the full backup capability of the Gen24, some of the IOs may actually clash with the DRM port IOs. This isn't a problem at all. So I'll just show you an example. So let's say we've got the backup power on here and we've got it set to full backup. We can see pin 0, pin 7, and pin 6 are default, and they're actually being used. And we've also got the DRM set to on, and we can see pin 6 here has multiple assignments and pin 7 has multiple assignments. So what do we do to fix that? So if ever we're using full backup and it's on, we can see here that all that needs to be done is DRM 1 and 5, we just change that to pin 10, DRM 2 and 6, we change that to pin 11. You can do this for every site that has the full backup set to on. And all that does is it moves the pin assignments to some unused pins to avoid the clash. Now, you do not have to change any of the wiring for your backup. You do not have to change any of the wiring for the GSD. The only thing that this is doing is to allow you to save the settings in the software because you can't save the settings if there is a clash. So these two pins aren't actually being used, and we're only using DRM 0, which you can see here is the pin 4 and 5 here. Okay, and here is the pilot board. So we can see the IO block just here, and that's what we're going to be connecting the GSD to. And we'll have a look on the next slide here. This is how you actually connect the GSD to the IO block. So the first thing we're going to do is connect the yellow wire on the RJ45 adapter to IO4, and we're going to connect the gray wire to IO5. And once this is done, the Gen24 is now ready to go, and the GSD has been installed with the inverter. Okay, so just to summarize, the only thing we need is a laptop or a smart device, and we need to have one GSD per inverter. So you cannot daisy chain all the Gen24s together. You'd have to have one GSD per inverter. And the steps were simply commission the inverter, set the IO mapping, and then connect the GSD to the DRM ports. Okay, so thanks everyone for listening to this presentation and wishing you a great 2023.